the final module of the Amazon Alexa Ruby course with Makers Academy. In this module, we will be authenticating skill users with OAuth. We'll be using the Relixa framework during this module. So we've constructed an intermediate skill called Pizza Buddy. This skill allows users to place pizza orders and query orders that have been made, as well as do other things like list toppings. In this module, we will authenticate users via Open Authentication, or OAuth, using Login with Amazon. Users will not be able to order a pizza until they're logged into their account, and users will only be able to list pizzas that they themselves have ordered. This kind of authentication is designed to work seamlessly with other user management protocols you might use in your application. We'll be creating a user entity from scratch, but authentication in this way can hook into Devise, Clearance, Sorcery, or any other authentication framework you might use. So before we can authenticate our users, we must enable account linking on our skill. Enabling account linking requires several pieces of information, and to get these pieces of information, we must set up a Login with Amazon security profile. If you would prefer to use another OAuth service to authenticate your users, then substitute the Login with Amazon setup steps with those of setting up your alternative provider. To create a new Login with Amazon profile for your Alexa skill, log into the Amazon Developer Console, click on Apps and Services, then click Login with Amazon, and click the button to create a new security profile. Create a new security profile, and we'll give it a name of Alexa Pizza Buddy. The description will just be Pizza Buddy, and we'll use Amazon's own content privacy notice URL, which is displayed below. You'll need to use your own. And we'll upload a simple image. I'm just going to upload an image of a pizza that I downloaded earlier. Hit save. And make a note of your client ID and client secret. Return to the account linking section of our Pizza Buddy skill. So we're going to enable account linking now. And we're going to fill out this form as follows. First up, the authorization URL is amazon.com/ap/OA. The client ID is the client ID from the Login with Amazon security profile. And this has a format that starts with Amazon1/application OA2 client. We're going to use the auth code grant rather than the implicit grant. And our access token URI is going to be api.amazon.com/auth/o2/token. Our client secret will be the client secret from the Login with Amazon security profile. You'll need to add a single scope. Login with Amazon supports several scopes, but for this example, let's use profile. This will allow Pizza Buddy to retrieve a full name for the user and greet them personally. And we're going to use HTTP Basic as our client authentication scheme. And while you're here, do make a notice of your redirect URL. You're going to need to use that to reconfigure the Login with Amazon web settings. It will either start with layla.amazon.com or pitangui.amazon.com. Let's save those requirements. And that's been updated. Our last step is to head back to our security profile and manage the web settings. In our web settings, we're going to need to edit the allowed return URLs. And that is where we can be redirected to once we have our authorization code grant. So once you've saved up this data, you're ready to send users an account linking card in the event that they are not yet authenticated with your skill. We'll just need to add a privacy policy URL, and we'll use the same privacy policy URL we did earlier. Nothing else needs to change here. We're still going to use the same HTTPS endpoint via ngrok. So now we've saved this data, we are ready to send users an account linking card in the event that they are not yet authenticated with the skill. So we've configured it. Let's update our launch request intent handler to send the user an account linking card if they lack an access token. So the workflow will be the user will say, Alexa, launch Pizza Buddy. And then Alexa should say, please authenticate Pizza Buddy via the Alexa app. When the user says, Alexa, launch Pizza Buddy, the skill will receive a JSON package, something like this, containing a session key and a user key and a user ID key. Here I've just redacted it. After the user has authenticated with login with Amazon, so they'll tap on the button to go and authenticate in their user app, they'll log in with their Amazon details. And then if they say, Alexa, launch Pizza Buddy, any subsequent requests to our skill will not just have a user ID key, they will also contain an access token, which will usually start with the word ATSA and then some kind of long string after that. And that's how we'll know that the user has been authenticated. And Alexa will then respond with, welcome to Pizza Buddy, would you like a new pizza? Or to list orders. So we can use the existence of this access token to tell if the user has authenticated with login with Amazon yet. Relixa provides us with some convenience methods for reading it and for sending the account linking card if the user has not yet authenticated. So let's go update our launch request now. We're just going to add a simple guard statement to return a tell, which will close the session to the user, with the words, please authenticate Pizza Buddy via the Alexa app, and the link account card will be attached to that using the card keyword. So Relixa gives us this link account card method, which will create the right kind of card. And we only want to send this in the event that the request does not have a user access token. If the request does have a user access token, then we want our skill to respond with welcome to Pizza Buddy. So this kind of guard clause will only work using the latest version of Relixa. So let's go look at that flow now using an iOS device. Echo. Launch Pizza Buddy.
Please authenticate Pizza Buddy via the Alexa app.
So as you can see on the user's device in their Alexa app, they're then prompted to link their account. They can hit the link account button and they will be taken to a login page where they need to log in to their Amazon account. By signing in, Alexa Pizza Buddy then asks for some specific pieces of information, and this is what we have set up by asking for a profile scoped information. If the user agrees, then they are redirected to the redirect URL where the Pizza Buddy skill is successfully linked. And if we now try again, echo, launch Pizza Buddy.
Welcome to Pizza Buddy. Would you like a new pizza or to list orders?
And you'll see that the user has been successfully authenticated. And I printed out the token that came through once it came here.
With the requested skill.
You'll see here that also at the end of that, since I didn't reply to the actual device, it sent through a session ended request, and we haven't implemented that. And Relixa has suggested a way of responding to that. So wouldn't it be great to welcome the user more personally to Pizza Buddy? Once the user is logged in with OAuth, we can access permitted Amazon customer data from the Amazon API. And while we're doing this, we will create or find a corresponding user entity in our database. So our ideal interface for the launch request intent handler would be something along these lines. We'll save this user to some variable and we'll use user.authenticate and we'll pass in the user access token. And then we'll use that information to say welcome to Pizza Buddy and then give the user's name. So let's set up a new user model that can save some key attributes, name and access token to start into the database. And we're going to test drive this implementation. So I have a user spec. We'll describe a basic user class. Let's save this up and run our spec. We'll watch it fail because we don't have a user entity yet. Let's create that user entity. Our spec test pass. So just as we did with the pizza, let's set up the test database for this particular interaction, this time auto-migrating only the users. Finalize will check that our models are configured correctly. And auto-migrate will update the actual database. Let's describe the simple case of saving to a database. We're going to do similar tests to how we did with pizzas. The user should start out unpersisted. That is, if we create a new user, it should respond to ID, but that ID should be nil. So let's make a new user. And then check that its ID is nil unless we've saved it. So running RSpec, there's no auto-migrate method on the user class. Let's jump into user and we'll start by requiring data mapper. I'm just going to pull it from the pizza, which is going to act as kind of a template for us here. And we'll also include data mapper resource in the user. We know we're also going to need several properties, starting with an ID, which will be a serial entity. That should be enough to pass our current test. Let's do a slightly more sophisticated database saving test. We'll make a new user, and we'll check that the properties are persisted properly. So let's make a new user. We'll call this user Timmy, and give them an access token of access token. This time we'll save the user, and then we'll retrieve them from the database by using user.last. And we'll expect the persisted user's ID not to be nil. We'll expect that the name on the persisted user is the same as the name we tried to save to the database, so that's Timmy. And we'll expect that their access token is the same as the access token that we provided earlier. Let's save that up and run that in RSpec. We'll watch that fail. So we don't have this name attribute on user yet. Let's go build that in. While we're there, we might as well also build the access token attribute. So name is going to be a string. It's quite a short one. The access token, on the other hand, we're going to, a string's not going to be long enough for us. It's going to be limited to too few characters, so we'll have to use this text entity here to store the longer string of an access token. So let's rerun those tests. And I made one mistake in my tests. I think I've passed the user one access token and I'm asking for a different one. So let's correct that up. And as expected, that passes. So now we have a basic user entity, serializable to a database. Let's implement a class method, authenticate method, on the user class. We expect this method to either find an existing user or create a new user, depending on their name and access token. That is, if the user does not exist, it should fetch their name from the Amazon API using their access token, and save their name and access token into our database, and then return that new user we just made. If the user already exists, that is, if there is a user with that name and access token in the database, then we'll just retrieve that existing user and we'll skip making the call. So let's describe the method we're planning to implement, authenticate. And we're going to get some kind of response back from Amazon here. So let's implement that expected response from the Amazon API. And it's going to be pretty simple. It's just going to be a little JSON packet with a single key, name, and the name will be the full name of the user. So we're going to have to pull out just the first name of the user after a little while. So I've set up this hash here and we'll convert that to JSON. We're also going to need some sort of client to pull down that Amazon request. So let's set up a double of the net HTTP Ruby built-in client. And when we call get on this double, it should give us the Amazon response. Great, so let's make our first test. It should create a user. Our authenticate method will create a user if one does not exist. So let's do a nice simple test for this. We'll expect that when we create a user with an access token, or when we authenticate them and we pass in our doubled client, it should change the number of users in the database, that's user.count, by 1. And count is a method given to our user by virtue of including the data mapper module. So we'll run RSpec, we'll watch that fail. Now we don't have access to this toJSON method yet inside when we're trying to construct this Amazon response. In terms of where that should go, well, we're going to use JSON within the user. So let's include the JSON library within the user class itself. We'll run RSpec, and we have a kind of failure we want. There's no authenticate method on the user class. So let's go ahead and define a class method called authenticate that takes a couple of parameters, an access token and a client. We are going to use the actual net HTTP library when we get round to it. So let's implement that and let's run that test now. Great, so it's expecting to have changed the user count, but our method doesn't actually do anything yet. So while we're here, let's just bring in the net HTTP module, and we're also going to need the URI module, but not just yet. So let's check that that still doesn't make any difference to our test. No, it doesn't. Great. So our method doesn't do anything yet. Let's go ahead and implement something so that it does. So the first thing we need to do is to construct a URI of the Amazon API URL. This Amazon API URL is https://api.amazon.com/user/profile. And then we also need to pass to it the access token that was given to us by the user. And that's how Amazon will then validate through the query params that it's allowed to give us this information. So once we've passed that URI, we'll need to require the URI module to do that passing. Once we've passed that URI, let's pull the first name of the user out of that response. So we're going to pass the JSON response that we get. We'll ask the client to go and get the URI, and our double will do that in our tests. And then we're going to go and get from this, I think it's the profile name key. Oh no, we can check the Amazon response we created. It's just the name key in there. Split on any spaces and do dot first. So this will do sort of specifically focused on European names where you have first name space last name. And then we'll just create the user using that name as their first name and the access token as whatever was passed in. So right now we just want our method to create something and we want that to work. Let's run RSpec. And that passes now. So we're now creating a user in the database. We don't know yet that it's creating the right kind of user. But before we go ahead, let's just refactor. We're going to need this string in a bunch of different places. And it seems meaningful in the program, so let's interpolate it in here as a constant. I'll pull this out. This is the Amazon API URL. And I'll just put it inside the user for now. We'll freeze that up so that it can't be changed during the course of the program execution. It's nice and clear to future developers. Our test still passed, so we haven't messed anything up. We've just done a nice refactor. Okay, let's add a slightly more complex test. This authenticate method should also retrieve a user if one with that name and access token does exist. So this time, before running our test, let's create a user with the right set of data. So we'll create a user with the name of Timmy and an access token of access token. So now we expect that when we authenticate the user using this access token and our doubled client, of course, we don't want to be making a real call. When we authenticate the user this time round, it shouldn't change the number of users in the database. It should just pull users out of the database. So this time we expect the authenticate method not to change the user count. We also expect that when we do retrieve this user from the database, using the access token and our doubled client, the name of this entity that comes out should be Timmy. So rather than Timmy Tails, it should have pulled out the first name correctly. And we should also check that when we authenticate this user, their access token equals the access token that we passed in. So standard sanity checking stuff for persisting things to a database. So when we run that test, we'll see a failure because our current method will try to create an additional user. It's changing the count from 1 to 2. Luckily, Datamapper gives us a really easy function for this using first or create. That is, it will retrieve a user if one exists and create one if it doesn't. So that succeeds and we're ready to go. So let's implement that now in our launch request. Well, we've pretty much gone ahead and done that, and we should be able to use it. So once the user has completed the account linking card, our application will authenticate, and then it will retrieve or save a user. And you can double check that everything's been set up. You should test this step using your Alexa device by saying, "Alexa, launch Pizza Buddy," and checking your Alexa app. So just as with the launch request user, we need users to be authenticated before they confirm their order. So we'll add an authentication guard clause to the first line of the confirm pizza order intent handler. Same as before, to confirm your order, please authenticate Pizza Buddy via the Alexa app, and we'll give them a link account card. This kind of has the effect of authenticating any routes that we want in our application only authenticated users to access. So we're only going to send that to people if their user access token does not exist. Users should own any pizzas they have ordered. So let's implement a has-many relationship between user and pizza. To do that, we're going to need to bring the pizza entity into our user class, and we're going to need to do the same in our pizza class a little later on. For now, let's add a simple has-many relationship so that users can own multiple pizzas. And let's implement the reflective relationship so that pizzas can belong to users. And we'll need to require the user class in relatively from the pizza. We'll also need to update the pizza spec tests for pizza to reflect this new requirement. If we run our spec now, we'll see a failure as the pizza is not being saved to the database correctly. And it's not being saved to the database correctly because it needs to belong to a user. So when we save the pizza in our persistence tests, let's just pass in a user ID as well. And it won't check that that user needs to exist, it just needs to have that in order to start the saving process. So now we can modify the confirm pizza order intent declaration so created pizzas automatically belong to an individual user. So let's authenticate the user using the access token that we now know the request will have. If the request doesn't have an access token, then they'll just be told to authenticate. And instead of making a new pizza, let's make a new user pizza. And that will automatically insert the user ID into our created pizza. And that's it. Ordered pizzas now belong to the authenticated user that ordered them. So let's start the server and test this out. So unauthenticated users should not be able to list any orders, but authenticated users should only be able to list orders that they've made. So we need to put an authentication guard into the list orders intent handler to block unauthenticated users. We'll say that if you want to list your orders, then you must authenticate Pizza Buddy via the Alexa app. We'll give them a link account card, and we'll only do that in the case that a user access token does not exist on the request. And to ensure that users can only list orders they've made, we'll authenticate users with an access token, and we'll scope the query for the number of pizzas that we're trying to retrieve only to pizzas belonging to the authenticated user. Now, if the user doesn't have any pizzas, of course, we need to just reply saying you haven't made any orders yet. So this is our good case, where the user has made some orders. We'll pull orders from any pizzas that have been created by the user, that is, pizzas that belong to this user. And we're pulling out the first 4 here. They may have made fewer than that. We're making an assumption here that they've always made more than 4 orders. If they haven't made any orders, then the response text is pretty simple. It'll just say, you haven't made any orders yet. And maybe give them a prompt to start, say, order a pizza. And last things last, we'll just send that request across the wire in line 21. So this concludes Module 6, which is authenticating skill users with OAuth. You can fork the completed application at the end of this module from the commit available in the written walkthrough. We have now covered all aspects required to build an intermediate or advanced skill using Alexa and Ruby. So go forth and build your own. Thanks very much for joining us.